right, welcome back, prep station. Okay, so we're still looking at resolution of vectors into components. Okay, I've already explained that this is another one. We have east 53 degrees north. So how do you represent this? Let's quickly look at the diagram. Now, east 53 degree north, that means you should stay on east while facing north. Stay on east while facing north. Now, if you look at the previous one, the one I just finished explaining, it was northeast. That was why the angle was in between the vector and the north. But here we have east before north. So the angle will be between vector and the east component. So this is the diagram representing that. So how do you break this down into components? The same method, east. So we have east followed by what? North. Remember the tip to tail method. Okay, so the second vector must start from where the tip of this other vector ends. So that is what you have here now. So with this, I have a right angle triangle. So it's now left for me to find the component. Of course, I have already done that, but let me still show you how to go about it. Remember, sine theta, cos theta. So if I'm going for sine theta, so that will be sine 53 degrees. Sine means opposite over what? Hypotenuse. So in this case, the opposite is y. So I have y over what? The hypotenuse, which is 5. Of course, if you make y the subject of the formula, then you have 5 sine 53. That's what I have here. That will give you 4 kilometers. The same applies to what? To the other components. Now, for the other components, since I've already used y, I will go for cos theta. So if I go for cos theta, of course, cos theta simply means adjacent over hypotenuse. So look at this diagram. Adjacent, the adjacent is x, okay? So that will be x over 5. So if you make x the subject of the formula, then you have 5 cos 53. And of course, if you play with that, you get 3 kilometers. Now, this is the right way to go about it. But then we have a shortcut. Since this is jam class, the shortcut is simply look for the angle that align. Okay, I always give my student this shortcut. The axis where the vector align should take cos theta. What does that mean? Let me quickly show you that again. The angle where the vector align should take cos theta. So if you know that, you don't need to go through all these cos theta and SOHCAHTOA y again. Now this is the vector, the red line. So where does this vector align to? Is it to the horizontal or to the vertical line? Now from what you can see, this vector is aligned to where? The horizontal line. So in that case, the horizontal line will take cos theta. The horizontal line will take cos theta. So the horizontal will take cos theta, while the vertical will take sine theta. I can do this for any vector. Now, what is my reason? This vector is aligned to the horizontal line. So since I know that, I can just simply say x is equal to the vector 5 cos what? 53. I don't need to go through the other method again, and then the answer will still be correct. You can see it there. So let's move forward from resolution. Example. Now find the resultant of the vectors shown below. Which vector? Let's look at the vector shown below. Okay, we have 2 vectors here. All right. Okay, I think I've already solved that. I will just explain the resultant of the 2 vectors. So here we have 2 vectors. Number 1 is 6 Newton acting at 45 degrees. Number 2 is 5 Newton acting at 30 degrees. So what do? Break this down into components. Do you still remember the component method? I told you. Yes, just look for the angle of inclination where the vector align, and then give that line cos theta, while the other line will take sine theta. For example, look at these vectors now. Let me see if I can break the angles in. Okay, the angles are not coming in. Let's go back. Now, this vector is aligned to x. This vector is aligned to x. Since it's aligned to x, x will take cos theta. Remember that? This other vector too is aligned to x, so x will take cos theta. So it means for this vector, x is taking cos. For this vector, x is taking cos. And then y will take sine for this vector. Y again will take sine for this vector. So see what I have here. For x, we have already determined which of the axes will take cos theta from what I told you about angle of inclination. So that is why you have all the cos theta coming under x. Can you see that now? And then all the sine theta coming under y. Another thing I need to explain is what is called the Cartesian coordinates. On the Cartesian coordinates, the line that runs from up top to down is called the y-axis. So up here is positive, down here is negative. This is horizontal line, the x-axis. So to my right is positive, to my left is negative. So if you resolve this vector to x-axis, it's going to fall on negative, okay? And then if you resolve this vector, here it's going to be positive. So that is why here, okay, for this vector, that is why you have negative. Look at the vector now, 6 Newton. You can see negative value here. Whereas for 5 Newton, you have positive value. Why? Is resolved to my right. And then for y-axis, the two vectors are all positive. Why? Because they are resolved to the top. If any of them is resolved to the bottom, it will be what? Negative. So after doing this, all you need to do is to add the vectors the way they are, and then get your value for x, get your value for y, and then find the resultant by taking the square of each of the components. So this is how you get your resultant vector, okay? We are still going to see more examples from past questions, so let's move forward because of time. All right, let's quickly look at past questions. How do we handle past questions related to this? Question 1, the resultant of two forces, 12 Newton and 5 Newton, is 13. What is the angle between the two vectors? The resultant of two vectors, 5 Newton, 12 Newton and 5 Newton is 13. Okay, so that means we have the first vector. Remember the tip to tail. This is the first vector. And then tip to tail, this is the second vector. So the resultant will be a line drawn from this point to this point. Okay, what are we looking for? We're looking for the angle theta. Now, this vector is 12 Newton. This vector is 5 Newton. And we have been told that the resultant is what? 13 Newton. So what will be the angle between the two forces? So we are looking for the angle between the two forces. So the angle between the two forces will be what? Yes, the angle between the two forces is 90 degrees. Why is it 90 degrees? Let me show you that again. It's 90 because they are perpendicular. Let me show you that again. It's 90 because the two vectors are what? Perpendicular. How do I know that they are perpendicular? We were told this is 13, this is 12, and this is 5. So if they are perpendicular, it means I can use Pythagoras theorem to resolve it. So what I'll do now, let's see if I use Pythagoras theorem here, I'll be able to get 13. And what does Pythagoras theorem say? Let's say this is x. So it means x squared will be equal to 12 squared plus what? 5 squared. Of course, 12 squared is 144. 5 squared is 25. So you have x squared equals to what? 169. So therefore, x will be equal to what? Square root of 169, which is 13. Okay? So since I've been able to get 13, it means the angle between these two vectors is what? 90 degrees. In other words, they are perpendicular. Now remember what we discussed before. If the two vectors are perpendicular and they are forming right angle triangle, then you can use two trigonometric identities, which is what? 1, Pythagoras, 2, Stochastic. So that is what I've just verified here. Let's move forward. Let's see another question. An aircraft attempts to fly due north at 100 km per hour. If the wind blows against it from the east to west at 60, its resultant velocity is what? Let's quickly do that together. Now, let's say this is the cardinal point. Always do this. The aircraft is flying how? North. So let's go for north. This is north. The aircraft flying north at 100 kilometers per hour. Then what happened? The wind is blowing against it from east to west. So the wind is blowing this way. So let's get the wind, the vector for the wind, tip to tail. This is 60 kilometers. So the resultant vector will be what? Just tap a line from this point to this point. So the resultant vector will be the resolving this. So this is a right angle triangle already. So what do? Use Pythagoras theorem. Let's say this is R. So I'll now say R squared will be equal to 60 squared plus 100 squared. So R will be equal to, that is 3,600 plus 100, 0. And so if you take square root of this, you are going to get 116 point something. Then approximately that will be 117. And then how do you get the angle? You can get the angle by simply saying tan theta equals to what? Opposite over adjacent. So the opposite here is 60, the adjacent is 100. So if you play with this and find the inverse of tan theta, I'm not with calculator, I would have done that now. So if you find the inverse of tan theta, you are going to get 31 degrees. So it's now left for us to choose the direction. So what do you think will be the direction from what we have done? So the question was from east to west. So that should be northwest. That should be northwest. Sorry. That should be northwest. So, yeah. So this is the answer. 117 kilometers per hour, north, 31 degrees west, because it was between these two cardinals, north and west. Let's quickly move. Let's see another question. All right. A body of mass 4 kilograms resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces. Calculate the acceleration. Now, how are we going to handle this? Simple. Perpendicular means 90 degrees. So let's quickly go. Vector 1 is what? 6 Newton. So this is 6 Newton. And then put an arrow. Remember, vector, they're represented by arrow. Okay. And then vector 2 is 8 Newton. So the resultant force will be dashed line to this point. Okay. So what is the resultant vector? Call it R. So let's find R. Of course, this is a right angle triangle, so you are free to use Pythagoras theorem. So R squared will be 6 squared plus 8 squared. So 6 squared is 36, 8 squared is 64. So that will give you 100. So it means R is 10 Newton. So if R is 10 Newton as resultant force, what is the acceleration? So at this point, we go back to Newton's second law, which simply says force equals to what? Mass times acceleration. So if you make acceleration the subject of the formula, then you have F over m. The resultant force is 10 over the mass is 4. So if you divide this, you get 2.5 Newton. So the answer to this question is 2.5 Newton meters per second squared. Sorry about this. This should be meter per second squared as the unit. Hope that is clear. Let's move forward quickly. Yep, that's the answer, 2.5 meters per second squared. Let's move forward. Which of the following quantity is not a vector quantity? Remember, I told you that vector quantities are quantities with what? Number one, they have magnitude. Number two, they have units. And then number three, they have direction, unlike scalar. So if you look at this now, we have velocity, we have work, we have force, we have electric field, and then magnetic field. So the vector quantity here is not, so the vector quantity here is work. Is not, is work. So let's go for a short break. I will be back.